All right, guys, we're gonna be working on 1.03 complex numbers, multiplying complex numbers. This will be a little bit of a challenge for some of us. I think we're gonna be spending a couple days on this. The whole technology thing is getting interesting. I recorded myself. I did this entire lesson very similar to this yesterday. Finished it, did everything, worked out everything, was talking, had a really good time. Then walked around there and realized I didn't hit the record button. So before I go any further, I'm gonna go around and make sure I'm recording. Solid. All right, beautiful. All right, so before we start multiplying, we gotta talk about I and what I is equivalent to. So we were told previously that I was equal to the square root of -1, right? And then if we squared the I, and squared the square root of -1, then I squared was equal to -1. So we covered that, okay? So if we look over here to what we have, I squared should be equivalent to -1. Now, I don't want to put the square root of -1 here because it doesn't make any sense. However, one thing is true. If I have 2 to the power of 1, what is that equal to? 2. If I have 400 to the power of 1, what is that equal to? Well, 400. So if I have I to the power of 1, what is that equal to? It is equal to I. All right? Hopefully we start to grasp that. I am going to erase some of this stuff because I don't want it to be all jumbled up. At the end of the day, we have I equal to I squared equal to -1. Bang. Bye-bye. So, now we have to determine I to the 3 and I to the 4. Well, if you know anything about exponents, you should know that you can split these up. So I to the 3, when you multiply like bases, you can add them, if you will. So I to the 3 is could be equivalent to 2 or I squared times I to the 1. Again, when you multiply like bases, I times I, you add their exponents. That's why I to the 3 is equal to I squared times I1. Times. You multiply like bases, add the exponents. Okay? So, if we have that, then I squared, we already know that I squared is equivalent to -1. And we know that I to the 1 is equivalent to I. So -1 times I is -I. I'm going to erase. Hopefully you can always go back. It's a video. You can rewind it and play it again if you got lost. Same thing occurs for I to the 4th. Can be you could have an I to the 3, but I'm going to do it I squared times I squared. Reason why? Multiply like bases, add the exponents, and that's the y. Okay? So I squared, we know, is -1. I squared is -1. What is -1 times -1? It is 1. So, here's a little kind of thing I always remembered because I coached for so many years and I would remember this. This is going to be a for loop, if you will. So in other words, it's going to repeat every 4 times as you go through. You only have to remember these 4 and then the rest of them you'll be fine. These are the main 4 you have to remember. The main 4 you have to remember. These being the crucial 2 that we're going to really use today with multiplying, but you still need to understand these next two as well. Again, going back to coaching, I used to always say I1, okay? Now obviously this is a 1 and number 1 and not 1, but it helps. I won. And as a coach, we would always say, listen, if you don't have anything good to say, kind of keep it to yourself. So then we would say, negativity stays in the middle. Keep it to yourself. Keep the negativity to yourself. So, I won. Negative on the inside. So you don't have to remember which one's which. This little thing will help you. I won, negative on the inside. That's the for loop, if you will. So now if we come over here, we're going to try to find a pattern. While this stuff here does not have anything to do with multiplying complex numbers, you will need to know how to do this. This little power of 4 or divide by 4, we're going to talk about that as well in a minute. But I don't really need that. So we already know that I is equal to I. And we know that I squared is equal to negative 1. I to the third is equal to negative I. I to the fourth is 1. Negativity on the inside. I won. Negative on the inside. So basically, if we think about it in those terms, if it's a loop, if you will, so basically what it's going to say is I won. So the next one of I won, I2, I3, I4, I5 will simply be I again. I6 will simply be negative 1. I7 will be negative I. I8 will be 1. So the question begs, why? Why is that? Why is that the case? I'm going to show you a little thing over here to the side that I always use as well. Since we're dealing with a loop of 4, I always think of 4 as money or quarters. 25 cents, 1 quarter. 50 cents, 2 quarters. 75 cents, 3 quarters, and $1, 4 quarters. Now we're only going to be paying attention to the quarters part or the cents part of it, or the remainder, if you will. What is remaining? You're either going to have 0.25, 0.5, 0.75, or basically 0.00, or it won't be there. Typically, if you put something in a calculator and it says 4, it's technically 4.0, but they don't put that. So if there's none of these little 25, 75, 50, then it will be at 0. So with that being said, we're going to talk about dividing by 4. So if I used this number and divided 5 by 4, I would end up with 1.25. If I took this number, 6 divided by 4, I would get 1.50. If I took this number and divided it by 4, I would get 1.75. If I took this number and divided by 4, I would get simply 2. So if you look at this now and draw the comparison, 0.25, I. 0.50, I squared, negative 1. 0.75, I to the 3, negative I. Basically, a 0's there. 1. And that's how you'll do these as we go through. So let's just do some off to the top. So I to the 11 is 11 divided by 4 equals 2.79. 0.75 is what we're looking at. 0.75 is I to the 3, which is negative I. So, why is it negative I? Why is it negative I? Let me erase a little bit up here since it's in the middle, and let me do that I to the 11, yeah. If I to the 11, no different than we broke these things apart, this is equivalent to I to the 4 times I to the 4 times I to the 3. Basically what you're looking at is trying to pull out as many of these I to the 4s as possible, because it's simply 1 times 1. Anything times 1 is just whatever it is itself. So I to the 3 is negative I. And that's why all of this is equal to negative I. That's how all of these will be done. So if it's a multiple of 4, if you will, so 120 divided by 4 is equal to 30. There's no remainder, it's simply 1. 159 divided by 4, I think that's 49? 59, 50, I don't know, hold on a minute. 10, 20, 30, 40s would be 39. That doesn't sound right. My brain is fried right now. 10, 20, 30, 40, is it 39? It is 39. 39.75. Yeah. 0.75, 0.75, I to the 3, negative I. Go through all of those again. Let me make something. My brain, I'm telling you, sometimes I'm getting joggled. Yeah, I'm right. I don't trust myself. 38 divided by 4 equals 9.50. I squared, negative 1. Okay? And so on and so forth. So if I do 133 divided by 4, that should be 10, 20, 30. It should be 0.25 somewhere. It should be 33.25. Gives me I. That's how these are going to work. So let's do I to the 14. So we're all here. 14 divided by 4 is 3.50. Negative 1. 101. 25.25. I. 17. 25 again. And I. 93. That's 23.25. Again, another 25, another 25, another 25, another 25. A lot of I's. And then 100 divided by is simply 20, so this is 1. Hopefully that makes sense. This little loop here, remembering these little things, I1, keeping the negativity on the inside, it will help you over time. All right, moving on. These These markers are pretty sharp as far as bright, so if I don't use the spray, my board turns like 5 different colors. Yay. Ah, beautiful. All right, let's roll them on up. Things change a little bit here, okay? Remember before, the only thing you're going to really need for multiples is to remember that I equals I and I squared equals -1. When I say multiples, I'm talking about multiplying complex expressions. These are the only 2 things you really need to remember for today. Okay? So, we're going to multiply, and these things get bigger and larger, and we're going to talk about as much as possible in here. So, again, we're going to go 7 times 5, distribute that, is 35. 7 times positive 3i is 21i. Real number, imaginary number, no like terms, done. Those are the easy ones. Those are the nice ones. You like to, that's easy. Let's roll, let's roll, let's roll. 3i times 2, 6i. 3i times 8i. So let's talk about how we do that, okay? Over here to the side. We would have 3i times 8i. Well, what you do with that is you multiply the numbers by each other. And then the i's by each other. A similar understanding of that is if I multiply 2x times 4x, I would end up with 8x squared. I'm not adding them. Operation. Multiplying. Okay? So now we have, where's my pen? There it is. 24i squared. Well, this is a little bit different. We got to recall this. This is the equivalent of 24 times -1. Which means I have 6i, 24 times -1 is -24. We have to write things in standard form. That means the number goes in front. And that's your final answer. So there will be some manipulation around here, okay? Please understand that. Some of this stuff you're going to have to manipulate multiple times. All right. 16i -4i squared. That second little part is -4 times -1. That's what that's equivalent to, which means I have 16i plus 4. It is not written in standard form, so we have to rewrite it in the form of a plus bi. It's not bi plus a. Okay, I'm going to leave that up there, maybe let that consume a little bit. Now we get different. Before we were multiplying a monomial by a binomial. Monomial by binomial, that's an individual thing. Monomial by binomial. Now we got binomial by binomial. When we do that, we use the old school term of FOIL. I'm going to do it 2 different ways. I'm going to do it with FOIL and I'm going to do it with Punnett squares. Okay? So you're going to see it both ways. And you use whichever way you like. Okay? 6 times 1, 6. First, outside, 6 times 2i. Inside, 5i times 1. Last, 5i times 2i squared. Okay? From here, we need to change the I squared. That's the one thing we can manipulate. So this right here is equivalent to 10 times negative 1. 10 times negative 1 is negative 10. When we do that, now we have multiple pieces to put together. That's our real portion, which is 6 plus negative 10, or 6 minus 10, which is negative 4. $12i plus 5i, 17i. This is using FOIL method. Please make sure that you write this stuff out. Make sure that you're manipulating this appropriately. Do not forget and call that 10i. 5i times 2i is 10i squared. It's not 10i. Same as you're multiplying up here. Remember this little thing here when you're multiplying i's, imaginary numbers by one another. Okay, I'm going to do Punnett squares for the next one, and what that is you're going to look like this, boxes. I'm going to take my first piece and have 4 and positive 2i. Then I'm going to take my next piece and I have 5 and negative I. This is where I get this from. Okay? If you use this format, it's fine by me. We can then go from here. 4 times 5 is 20. 5 times 2i is positive 10i, and putting that sign in there will help you be consistent. Negative 1 times 4 is negative 4. And, oh, I'm sorry, that's a negative I. See, I messed up there. Sorry, that's an I. So that is negative 4i. Negative 1i times 4 is negative 4i. Please be careful with that. And negative I times positive 2i is negative 2i squared. So now we have all our pieces in the box. This negative 2 times negative 1, which is 2. Give me a different color. Let's go pink. Pink looks nice. Now inside the box we have a whole number of 20, a whole number of 2, which is 22. Cancel. Cancel. Negative 4i, positive 10i, plus 6i. FOIL method, Punnett squared. I use this because this is what I grew up doing. This doesn't bother me in the least. This makes a lot of sense. The only thing is I have to be consistent is when I rewrite these, I put that negative 1 there instead of negative I. That's kind of scary to me. I like to do this personally. Least likely to make mistakes. But to some people, this is literally like a foreign language. So you can use that. As long as we're getting back to this and we're understanding real A plus or minus BI. Real A plus or minus BI. I'm going to use number 6 as a FOIL. So I'm going to have negative 6 times negative 3, which is positive 18. I'm going to have negative 6 times negative 9i, which is positive 54i. Then I'm going to take 5i, multiply it by negative 3, which is negative 15i. And 5i times negative 9i, which is negative 45i squared. Now, remember how I do all these circles and all that stuff? For me, when I look at that, I got negative 45 and I squared. Automatically, I know it's positive 45. Negative 2i squared, positive 2. Positive 10i squared, negative. It just flips the sign because you're multiplying it by negative 1. If it's negative, it becomes positive. If it's positive, it becomes negative. So at this point, I have 45 and 18, which is 63. $54i minus 15i is positive 39i. A plus BI. Okay? Standard form, standard form, standard form. Take a little screenshot of that or whatever the case may be, and we're going to roll on to the next ones. The next ones get a little tricky. Promise, the next ones get a little tricky. Okay, so please understand, a little bit tricky. Oh, please, I hope I'm still recording. I did this whole thing yesterday. Cannot believe it. Got around there, nothing. Whew. Tell me what. No, here we go. There it is. I made it. I know what I did. Let me go back. Sorry if I'm jumping around. That's not what I wanted to do. That is not what I wanted to do. That is what I wanted to do. So now I have the last three. Okay, this gets a little tricky. Monomial times a binomial times a binomial. Binomial squared. Binomial times a binomial times a binomial. I will tell you, first thing you need to do is try to get to two binomials in which you can then use FOIL or a Punnett square. That's the easiest way. So eliminate these two things to get one, okay? So this is 3 times 4, which is 12. And 3 times 3i, which is 9i. This one simply comes down. And now you're back at what we had before. It's just one more little step, one more understanding of how to do it. 12 times 4, 48, first. Outside, negative 3i times 12i. Inside, 9i times 4. Nine I times negative 3i. Yesterday we were adding, today we're multiplying. Please don't make that 6i, okay? You have to see and recognize your operations. All right, so what we have here is really, 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 really nice. It just worked out that way as these bad boys right here in the middle go dunzo. They cancel each other out. Positive 36i minus 36i is 0. Doesn't count. That's awesome. Got rid of that real quick. Now we look at this. We have negative 27 times negative 1, which gives me a positive 27. At that point, let's pick this color. Positive 27, 48 should be 75. There's no imaginary part. So what you just saw there is the fact that we multiplied a monomial, a real number, times an imaginary or a complex number times another complex number, and we ended up with a real number. It is very, 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 very possible. And the reason why, as I'm about to show you, these things here, and I didn't want to say it just yet, are what we call complex conjugates. They're both complex numbers that are conjugates. The reason they're conjugates, because the sign in between them is opposite. When you multiply complex conjugates by one another, the complex number goes away and it becomes a real number. It's as simple as that. So if I'd multiplied those together first, you would have seen it would have been a real number, which would have ended up being 25. I could look at that and tell you that, and some of you guys, I'll tell you the shortcut, and if you know the shortcut, pipe in to the lesson when we do this, and it's an easy one. But some of you, if you're not mathematically inclined, will probably never see it. But it's something there that stands out that would make me be able to come up with 75 without doing all of that. Anyway, for the rest of us, we got to do all that. All right, so here we have squared. What does that mean? Well, if I had 4 squared, that simply means 4 times 4, right? So what this means is 3 minus 2i times 3 minus 2i. These are not complex conjugates. These are not complex conjugates. The sign is the same. For complex conjugates, the sign is opposite. Okay? So, multiply. 3 times 3, 9. 3 times negative 2i, negative 6i. Negative 2i times 3, negative 6i. Negative 2i times negative 2i, positive 4i squared. You multiply negative 2 times negative 2, 4, I times I squared. Okay? You'll notice here, when they were complex conjugates, these inner pieces, or these little imaginary numbers, go bye-bye. They disappear. Here, they do not. They are the same. So negative 6i minus 6i is negative 12i. So my b would be equivalent of negative 12. A plus bi. Here, this is 4, positive 4 times negative 4, which is times negative 1 is negative 4. 9 minus 4 is 5. So my A is equal to 5. My B is equal to negative 12. Okay? A plus or minus BI. The next one's going to be a little bit tricky because there's a whole lot going on. Do you recognize what goes on number 9? Do you recognize, going back here to complex conjugate, 4 plus 3i, 4 minus 3i. Here I have negative 2 minus 2i, negative 2 plus 2i. So what that is these two change. The negative 2's out front do not change. The A does not change. The B changes. Okay, the sign of the B will change. So with that being said, I can tell you when I'm going to multiply these two things together, this is going to be equal to 8. We're about to do it, but when I multiply these two things together, you're going to get a number of 8. Let's do it. I'm going to use FOIL again because that's my preference. Negative 2 times negative 2 is 4. Negative 2 times 2i is negative 4i. Negative 2i times negative 2 is positive 4i. Negative 2i times 2i is negative 4i squared. Negative 4 times negative 1 is 4. Negative 4i plus 4i goes bye-bye. So now I have 4 plus 4, 8. Yay! If you can figure out the shortcut to that, let me know. Let me know. But unfortunately, we're not finished because we still have this piece that's got to come down to here. That was just multiplying those two binomials together, which happen to be complex conjugates. Now we have to deal with this bad boy, which says 8 times 7 is 56. 8 times 8i is 64i. And that is your final answer. Again, went through multiplication, talked about complex conjugates. Hopefully we can understand. We're going to talk a little bit more about complex conjugates. Understand that when you square a complex number, it's simply multiplying by itself. When you multiply by itself, it's not the conjugate. The conjugate is when you multiply by a complex number where the B sign, or the sign for the B, is opposite. Some good examples would be 2 plus 6i, 2 minus 6i. Complex conjugate. 4 minus 3i, 4 plus 3i. The signs change. What if I had like this one, negative 8 plus 2i? What would the next one be? What would its conjugate be? Negative 8 minus 2i. The only things that are changing are those. We could additionally have this. Square root of 3 minus 4i. What would its conjugate be? Square root of 3 plus 4i. What would this, let me see if this is in the screen. If it's not in the screen, gotta get it in the screen. There we go. Let me rewrite it over here. For those of you guys who think you know what's up, I can tell you without question, if you multiply this out, this answer right here would be 19. Multiplying those complex conjugates. See if you can tell me the shortcut. See you tomorrow.